Good morning, guys. Today we're going to look at graphing quadratic functions by finding their vertex and their intercepts. As you can see here, we have a quadratic function in standard form. Standard form means that we have the linear term and the quadratic term easy to see there, or obvious right there. There's not a single term or a single x. There's both kinds of x's, x to the second and x to the first. That's what's making it standard form. From that, we can look at this a, b, and c as the coefficients and be able to calculate the vertex, the axis of symmetry, and all this other stuff. Now, just kind of stepping to the side for a second, remember the graph of a quadratic is going to have this U shape to it, but has the name called a parabola. So a quadratic function's graph is called a parabola. So if we want to find the vertex, this minimum or maximum point, we have this little formula. This little formula says that x is equal to negative b over 2a, and then the y-coordinate is whatever we get out of that. And you can see that from this axis of symmetry. Axis of symmetry is a vertical line that runs right through the center, or right through the vertex. Vertical line that runs right through the vertex. And our function, or our graph, is symmetric on both sides of it. That's why we call it the axis of symmetry. So if the axis of symmetry is x equals negative b over 2a, and it runs vertically through the vertex, then that means our x-coordinate for our vertex must be negative b over 2a. The way we find our y-coordinate of our vertex, is remember a vertex is just a point, an x and a y. We just take what we got for x and plug it back into our function to get y. So we've got our x and our y. The other key points we want to get to be able to graph these when we're in standard form is the intercepts. And we have the x-intercepts and y-intercepts. X-intercepts are what we get when the function is equal to 0, when it has no height. So these 2 points will come from putting y in for 0, or 0 in for y, and then just solving your function. And we should get 2 of them unless we get non-real solutions, or if we get a single real solution, and we'll look at examples of those. Then we go into y-intercepts. Y-intercepts are what we get when we plug 0 in for the x-coordinate. You remember all that from your linear functions. Well, if I plug in 0 for this x and 0 for that x, those terms will cancel out, so all we're going to be left with is the constant. So just like in your slope-intercept form, y equals mx plus b, well, the y-intercept was the b, was the constant in that case. Y-intercept is still going to be the constant in this case. So we've got these little formulas here to get vertex and axis of symmetry. We can set it equal to 0 and solve to get x-intercept. We can take the constant and get the y-intercept. And then we can just double check all of that by making sure that our direction matches up. And we notice that if a is a positive number, then the graph will open upwards, kind of like we have there. If a is a negative number, then the graph will open downwards. I kind of like to think of it as a is positive, he's in a good mood, he's smiling, see his smiley face. If a is negative, he's in a bad mood, and he would be frowning, so he would be opening downwards. All right, a lot of information there, so make sure you've got that copied down because we're going to refer back and forth to it. Give me a second, I'll get a couple of examples up here so we can actually go through the calculations and manipulations to be able to graph a couple of quadratics that are in standard form. Okay guys, here we go. We have an example right here. Let's find the direction and axis of symmetry for this function. Then we'll go through and find the components so that we can graph it. Direction, we look at A. Well, before I start doing anything with quadratics, I always like to label. Remember, A is your lead coefficient, B is your coefficient on your linear term, and C is your constant. So direction, we look at A is equal to positive 1, and we said if A is positive, it opens upward. Alright, so our final graph should end up opening upwards. Next we look at axis of symmetry. Remember your formula for axis of symmetry, x equals negative b over 2a. So negative, negative 2 over 2 times 1. So 2 over 2. So x equals 1 is going to be our axis of symmetry. And we could go ahead and plot that. So we could go over to positive 1. We could draw that axis of symmetry. So we've got that x equals 1, axis of symmetry. That's taken care of. All right, now we want to actually graph. We want to find the vertex. Remember the vertex, we already have the x-coordinate. It's the negative b over 2a. It is the axis of symmetry. Once we have the x-coordinate, we just plug that back in to get the y-coordinate. So we take y equals x squared minus 2x minus 3, and we put in the 1. 1 squared minus 2 times 1 minus 3. Remember, do your order of operations. So 1 squared is 1, 2 times 1 is 2, and 3. So 1 minus 2 minus 3 should be negative 4. So our vertex ends up being the point 1, negative 4. So we got the 1 from the axis of symmetry. We got the negative 4 by plugging that 1 into our equation for x. And we got our vertex 1, negative 4. So let's plot that point. So there's our 1, so that's going to work out fine. So that shows that we did that correctly. And there is our vertex 1, negative 4. And now as we go on through, let's find the y-intercept. Y-intercept, we said, is what we get when we take our equation and put 0 in for x. So 0 squared minus 2 times 0 minus 3. Well, 0 and 0 gives you negative 3. So we said you can shortcut that just by grabbing the constant every single time. So y-intercept is at negative 3. So we can see it's starting to match the opens upward, right? If this is the vertex, then our graph's got to go up to be able to hit that y-intercept. All right, so let's write down the vertex real quick. 1, negative 4, and, y-intercept is going to be over 0, down 3. So 0, negative 3. Remember, I can't go up and then come back down because your vertex is either going to be your highest point or your lowest point. Okay? So you can't have, so in this case right here, I can't have this be the vertex and then go up and come back down, because then that wouldn't be the highest point. All right, so it's going to have to be the lowest point. So our graph's going to have to go this way. It's going to have to open upward. So it all fits together and checks. Let's finish the picture by getting the x-intercept. X-intercept, we said, is where we take our function and set it equal to 0. So 0 equals x squared minus 2x minus 3. And we go through and we use any of our techniques for solving. We can factor, we can quadratic formula, we can complete the square. This one I recognize factors pretty quickly. X minus 3, x plus 1, right? X squared is x and x. Negative 3 is negative 3 times positive 1. Check it. Negative 3x plus 1x gives us the negative 2x. So we go through, set each factor equal to 0, x equals 3, x plus 1 equals 0, x equals negative 1. If you don't remember how to do that, go back and check the lecture that talks about solving quadratics by factoring. But there it is. There's our two x-intercepts at positive 3. So we're at 3, 0, and at negative 1. So we're at negative 1, 0. Then just connect the dots. As you can see, we are symmetric, right? The x-intercept is, this x-intercept is 2 units to the right of our axis of symmetry. This one's 2 units to the left of our axis of symmetry, or to our vertex. So that just, the axis of symmetry, the direction, it all just kind of works as a double check to make sure we've done our calculations and everything has come through. So this is how we would graph using vertex and intercepts. That's all the work to it. So it's the best way to do it if you're already in standard form. Just a couple of quick calculations. If you'll give me a moment, I will get another example up here for you guys to try. Okay guys, here you go. Take this function right here. Oh, forgot to change that. This is number 2 for example 1. Take this function right here, f of x equals negative 1/3 x squared minus 2x minus 3. I want you to identify direction and axis of symmetry. Then find these bits of information so that you can put it all together and give me a graph for that specific function. Take a minute, pause the video, and I'll wait right here while y'all work that out. Okay guys, hopefully you were able to get all this information in the graph. Let's check your work and see how you did. First off, let's look at the direction. We're looking at A. A is equal to negative 1/3. We know that if A is negative, then the graph opens downward. Axis of symmetry. Axis of symmetry, we use the formula x equals negative b over 2a. So we have negative 2 over 2 times negative 1/3. Clean it up. Positive 2 over negative 2/3. Multiply by reciprocal times 3/2. So you end up getting negative 3 when you simplify all that down. So x equals negative 3. That's something we can go ahead and graph. So 1, 2, negative 3. So there is our axis of symmetry. X equals negative 3. Now let's find all the other components to be able to graph that. Vertex, we already have the x-coordinate. So we take that and plug it back in. Oh, forgot to label. There's A, B, C. So I'm going to take y equals negative 1/3 times x, which is negative 3 squared, minus 2 times negative 3, minus 3. Go on through, make sure you do your order of operations. You're going to do your 3 squared before you multiply by negative 1/3. So that's 9 times negative 3. So, sorry, times negative 1/3. So 1/3 of 9 is going to be negative 3. 2 and 3 is positive 6, minus 3. So we get negative 3 is negative 6, plus 6 is 0. So all that together gives us a vertex of negative 3, 0. So we can go plot that now. Okay, right here, negative 3, 0 is our vertex. Let's get our y-intercept. Y-intercept is just the constant, but we'll go ahead and do the arithmetic on all of it too, just to keep confirming that for you. So y equals negative 1/3 times 0 squared, minus 2 times 0 minus 3. So 0 minus 0 minus 3. So y-intercept is negative 3 also. A lot of negative 3's in this problem. So 1, 2, negative 3. So 0, negative 3 is our y-intercept. Okay, and that kind of just confirms what we had before. That means that we have a maximum in this case. So our maximum value is going to be 0 because our graph is going to open downward. So the vertex gives us the high point on this graph. All right, let's finish the x-intercepts, which we should kind of see already because we see right there that the vertex is on the x-axis, making it the x-intercept. But let's look at what happens when we solve here. So we set it equal to 0, so negative 1/3 x squared minus 2x minus 3 equals 0. Here's another one that can factor. If you don't see that, just clean it up. Get rid of this negative 1/3 by multiplying the whole function by negative 3. And give you a little bit easier numbers to work with. Negative 3 times negative 1/3 is 1x squared. Negative 3 and negative 2 is 6x. Negative 3 and negative 3 is positive 9. So that one is pretty easy to see that it factors because it's x plus 3 times x plus 3. Set each factor equal to 0 and solve. So we get x equals negative 3, x equals negative 3. So we end up getting the same value for both of them, which just confirms what we had right here. So negative 3 is our one and only x-intercept, and it happens to be the vertex. Well, and that's the way it'll always be. If you only have one x-intercept, it has to be the vertex. So we got the x-intercept, we got the vertex. When we connect the dots, we get this picture right here. Well, we know a parabola needs to have two halves to it. So we're going to have to use what we know about this axis of symmetry to complete the picture. Since we didn't have two x-intercepts to give us both halves, we're going to have to use that idea of being symmetric. So if I had to go 3 units to the right to get to here, 3 units to the left should put me at the same value. So 3 units to the right and down 3 is a point we knew. So for symmetric, 3 units to the left and down 3 would be another point we know. Okay? So that's going to give us the overall shape and picture of this specific graph. That's how you go through and graph using intercepts. If you'll give me a few minutes, I'll get some examples up here and we'll look at how to take excuse me, how to take standard form and write it into vertex form using this axis of symmetry formula. So here we have the two different ways we can write a quadratic function. We can write it in standard form as we've been looking at, f of x equals ax squared plus bx plus c. We could also write it in what's called vertex form, where we have f of x equals a times the quantity x minus h squared plus k. The reason we call it vertex form is because this h and k is the vertex of our function. So without having to calculate vertex like we did here, negative b over 2a to get the x coordinate and plugging that back in to get the y coordinate, we can just read what's inside the parentheses and outside the parentheses to be able to determine if we are what our vertex is, where our starting point is. So there's a lot of value in working off of vertex form. Now this is how standard form and vertex form, the components, relate to each other. The a is still the same thing in both of them. It's still your lead coefficient. It's still going to tell you your direction. And then the h is the x coordinate, negative b over 2a. And the k is the y coordinate, which is going to be what you get when you plug in negative b over 2a. So if I have a function such as this one, f of x equals x squared minus 6x plus 4, and we want to write that into vertex form, all I really need is a, h, and k. Well, a is already taken care of. We know that. A is this lead coefficient of 1. So a is equal to 1. That part's done. We need to figure out what h and k are. Well, h is the x coordinate, negative b over 2a. So h is negative b, there's my b, so negative 6 over 2 times a is 1. So 6 over 2 equals 3, so h is 3, so we're putting it together, and then we finish off by getting k. K is what we get when we plug h back in. So we're going to take k and say that's equal to our equation, x squared minus 6x plus 4, where we've plugged the 3 in. So just plug the 3 into both slots and that'll give us our k. So we get 9 minus 18 plus 4. 9 and 4 is 13, minus 18 is negative 5. So we have a, we have h, we have k. Now we can write it in vertex form. F of x is equal to a, which is 1, times x minus h. H was 3. Quantity squared plus k, and k was negative 5. So we can just make that minus 5. So that is how you can take standard form and turn it into a vertex form using your axis of symmetry formula, your x-coordinate of the vertex formula. Give me a second, I'll get another example up here for you guys to try. Here we have I have two problems up for you. One, just like the last one we did, take this function, write it in vertex form from standard form. This one you're given a couple of points, the vertex and a point that the parabola passes through. I want you to see if you can take that information and come up with the standard form of the function given that information. If you will pause the video here, take a couple moments to work it, I'll hang around and wait for you to finish. So hopefully you were able to come up with an answer to both of these. Let's go through and check your work, see how you did. All right, so first thing we know we need to do is identify A. So A is still A, that's the 2. There's A, there's B. Now, because we don't need C at the moment to be labeled as C, but if you want to, you go ahead and label it C. So we have our A, we need our H. H we know we use the formula negative B over 2A. So negative 4 over 2 times 2. So negative 4 over 4 is equal to negative 1. And then K is what we get when we plug that back in. 2 times negative 1 squared plus 4 times negative 1 minus 2. So we're going to get 2, because negative 1 squared is 1, so 2 times 1 is 2. Minus 4 minus 2 is going to give us 2 minus 2, which is negative 4. So K equals negative 4. So we have our vertex form. F of x equals A, which is 2, times x minus h, which is 1. So minus negative 1, plus K, which was negative 4. Oh, don't forget your quantity squared on there. And then clean it up. F of x equals 2 times x plus 1, quantity squared minus 4. So that's the vertex form of this function that was written in standard form. So we can easily see what the vertex and the direction are from that. All right, on this one over here, they give us a vertex, they give us a point. So it's kind of like when they give you slope and a point in linear equations, use point-slope form. Well, if they give me vertex and a point, I'm going to use my vertex form. So vertex form, they've given me h and k, and they've given me x and y. So if I take my vertex form, y equals a times x minus h, quantity squared, plus k. Well, we have the vertex. The only thing we're missing, just like over here, we had the h and k, so we had to figure out what the a was. And we needed the h, the k, and the a. Well, here we have h and k. We need to figure out a. So we're going to use these points, these values, to be able to solve that. So all we're going to do is just do a substitution. That number is going to go for h, that one for k. That number for x, that number for y. So we'll have everything accounted for but a. We just find a and we'll plug it back in. So y was equal to 4. A we don't know yet. X was 1. H is negative 2. K is 3. Go through and do the arithmetic. 1 plus 2 is 3. 3 squared is 9. Move your 3. So we get 9a equals 1. So a equals 1/9. From there, we know that we have y equals a, which is 1/9, times x minus the x coordinate. So x plus 2, quantity squared, plus 3. So we have our vertex form. Now we need to turn that into standard form. Well, we know how to turn standard form into vertex form. Vertex form into standard form is even easier because you've been doing this since Algebra 1, and all it is just distributing and combining like terms. So let's move it up here. And give ourselves some room to work. So we have f of x equals 1/9 x plus 2 quantity squared plus 3, and I want to distribute that. Now remember, exponents do not distribute across addition or subtraction. Exponents are shorthand for multiplication and division, so that's why it can distribute across multiplication and division. Second thing we're going to notice, I can't distribute this 1/9 to the x plus 2 because 1/9 has an exponent of 1, while the x plus 2 has an exponent of 2. They don't have the same base, they don't have the same exponent, they can't distribute. So what I've got to do is change this x plus 2 quantity squared into something that I can work with. Well, let's multiply it out by hand instead of trying to distribute. We know that square means to multiply a number by itself twice, or a quantity by itself twice. So when we see x plus 2 squared, when you see anything that has a plus or minus inside with an exponent, that means write it out that many times and actually go through and do the distributive property of multiplication and not distributing exponents. So we get 1/9 x squared, 2x and 2x is 4x, 2 times 2 is 4, plus 3. Now, exponent of 1, we can go through and distribute this 1/9 to all three terms inside. So 1/9 x squared plus 4/9 x plus 4/9 plus 3. So we can see that f of x in standard form is 1/9 x squared plus 4/9 x plus, what's that going to be? 27 over 9, so 31 ninths after you get your common denominator. So that is the standard form of the function that has those two characteristics. So we use the vertex form to get us started, then it's just distribute and combine like terms to get it into standard form. So really, vertex form is just the factored out form of our standard form of a line. So it's not just two separate equations that happen to say the same thing. They're the same equation, they're just written in different forms with the numbers just combined in a little bit different manner. That's everything for graphing using vertices or using vertex and intercepts. Remember, the vertex, x coordinate is negative b over 2a, y coordinate's what we get when we plug that in. X-intercepts are what we get when we set it equal to 0. Y-intercepts are what we get when we plug in 0 for the x. That's it, just a couple of those few key things to remember, and I will see you in class tomorrow, guys.